Welcome to my video for this week. This is week 3, and we're going to discuss linear systems. Systems of linear equations and ways to solve. First method is graphing. The second method is substitution. And the third method is elimination or addition. And I'd like you to check out the book for that one. We will not address that in this video. A set of equations is called a system of equations. The solutions must satisfy each equation in the system. If all the equations in a system are linear, the system is a system of linear equations or a linear system. Now I'd like you to take a look at all three types of systems you're going to see. The first is consistent, and that means they are intersecting lines, and there will be one point where the lines intersect. That is called the solution. As you notice, I have all the points labeled, the x and y intercepts. The solution I have highlighted so that I specifically make that so that you can see it very clearly. The next system we're going to look at is called an inconsistent system. Inconsistent means when you solve the equations to graph, you're going to find that they are parallel lines. That means the lines have no points in common and they have no solution. Again, watch my graph etiquette. And the third system is a dependent system. A dependent system is when you solve the equations to graph, you find that they are the exact same equations, and therefore the two lines lie one on top of the other. Again, that's the same line, and there is infinite number of solutions for that system. I'd like to review graph etiquette for you. Solving systems by graphing. Always label and put arrows on the ends of your lines and axes. Use graph paper and make sure you show all your work with the graph on the graph paper. Make sure you label the axes, the lines, the points of intersections, the x and y intercepts, equations for the lines. Show the table or method used to find the graph, and use checks. And that means to check the point in both original equations, or maybe both of three equations when we get to systems that have an x, y, and a z in them. I'm going to use these two equations in the upper left-hand corner and tell you that they are a system of equations. And I'm going to use the x and y intercept method to graph. I'm going to take the first equation, and when I plug 0 in for y, then I can solve for the x-intercept. That gives me the x-intercept of 1, 0. And as you can see, I plotted that on the graph. Next, I'm going to find the y-intercept with that equation and put 0 in for x. That gives me the point 0, negative 2. Please review this technique if you're not familiar. So now I have 2 points, 1, 0, and 0, negative 2 on the blue line. The next equation, x plus y equals negative 2, I'm going to use the same exact method. To get the x-intercept, I'm going to put 0 in for y, and that gives me x equals negative 2, 0. Then I'm going to put 0 in for x and find the y-intercept, and that's 0, negative 2. And you'll see that on the red line or the pink line, whatever color you want to call that. I used the x and y intercept method to find those intercepts. I found this to be a consistent system with an intersecting point of 0, negative 2. And if I ask you to check that, then you'd put 0, negative 2 in both original equations to make sure it satisfies those equations. The next method we're going to look at is substitution. Step 1, we're going to solve one of the equations for x or y. And as you can see, the second equation is already solved for y. Step 2 is we're going to substitute that piece 3 plus x into the y in the first equation. Then we will solve that and we'll get 2x plus 3 equals 5. If I subtract 3 from both sides, I get 2x equals 2. Divide by 2, I get x equals 1. That's half of my solution. Next, I'm going to plug that 1 back into the other equation to solve for y. And actually, you can plug it into either equation. When I plug that into x plus y equals 5, that gives me 1 plus y equals 5, and y would equal 4. Check my solution in both original equations. The 1, 4 is my intersecting point, and I'm going to plug that in both the x plus y equals 5. So that gives me 1 plus 4 equals 5, and that's true. Then I'll plug it in the other equation, 4 equals 3 plus 1. That does check, and that makes this a consistent system with one point of intersection. Please refer to the book for the elimination addition method of solving linear systems, and I hope you paid attention carefully because I will be asking you a PS question on this video. Have a good week.